Hello and welcome to the first instalment of Unit 3, Outcome 3 for Physics, Sunbury Downs College. Today I'm going to be introducing the topic of further electronics, what it actually involves, what it means, and some of the basic concepts that we're going to be using over the coming couple of weeks. So, further electronics. What are we trying to achieve with this unit? Well, if we look at this drawing here, we're talking about, in this unit, the interface between this and this. Okay, the interface between power outlet in your home and an appliance, such as a computer. And we're asking, what happens in between these two things? Okay, so the power outlet produces power of the form of alternating current. The computer, you may know, uses a different form of electricity. It uses direct current. So how do we get between those two things? How do we convert alternating current into direct current so that it can be used by an appliance? So the first thing to talk about is the differences between alternating current and direct current. We're going to start off by talking about alternating current, or AC. Alternating current. So what does it actually mean? Well, this graph here represents a voltage in an alternating current system. But it's a little bit difficult to talk about this graph in isolation. Let's actually put up a circuit diagram that shows what's actually happening there. So this is a voltage, and this is a circuit containing alternating current. This symbol here represents the power supply. Okay, this is the symbol for an alternating current power supply. So we have a circle and then a little fraction of a sinusoid in there, a little squiggle. Over here we should recognise this is a symbol for a resistor, so that's the load in this circuit. And we're measuring an output voltage. We're measuring V out across here. So that's the voltage across the resistor, positive and negative. So we can say that this graph here is a graph of that voltage, V out. And it's a graph of V out against time. So as time changes, V out is also changing. Okay? To begin with, we see that V out is increasing, then it reaches a maximum, then it drops away. So the voltage across this resistor increases to a certain point, it drops away to 0, and then it becomes negative. Okay? So this line represents a 0 voltage, and it's below the line we have a negative voltage. What does that negative voltage mean? That basically means that the positive and negative here have reversed. Okay, the voltage across this resistor, this load, has now changed so that the positive is here and the negative is here, which means that current, conventional current, which was originally flowing positive to negative in that direction, is now flowing in that direction. To help us visualise that, okay, I have two little electrons here, okay, and we think of these as being electrons moving around the wire in the circuit. So here they are, they're in this wire. Now to begin with, we have a positive voltage, which means voltage is in this configuration, and conventional current is flowing from positive to negative. But we know that electrons have negative charge, and they actually flow in the opposite direction to conventional current. So while conventional current might be flowing that way, electrons are actually flowing that way, back around that way, and they'll start out flowing back in this direction. Okay? Alternating current, they flow in this direction, voltage is positive, so conventional current continues in this direction, and electrons continue in this direction up to this point. When the voltage is reversed, conventional current reverses and electrical current reverses. So they start flowing in that direction, and then they go back in this direction, and then back again, and then back again. And basically, the electrons in this wire are continuously oscillating backwards and forwards. They still serve the function of electrons in any other electrical circuit in that they're moving, and that's what transports electrical energy, but they're not moving in a uniform direction. They're moving backwards and forwards. Let's now compare that to direct current, or DC. So in a DC circuit, we have a different type of power supply. Okay, we don't have a variable power supply like this. We usually use a simpler symbol for a battery. Okay, like that. A battery has a long side and a short side, and the long side represents the positive and the short side represents the negative. Okay, when I try and remember what's the positive, what's the negative side, I think if you want to draw a positive symbol, a plus, you need twice as much line than you do to draw just a negative. And there's twice as much line here as there is here. Don't know if that helps. And if we were to draw a graph of the voltage at V out for something like this, it would no longer be changing. Okay, we wouldn't have that alternating current. We'd have a constant value. Okay, we would have a constant voltage across this resistor, because that's what batteries are supposed to provide, a constant voltage. And then if we talk about what the electrons are doing in this situation, the electrons aren't moving backwards and forwards, they're moving in a continuous direction. But which way are they going to go? Now, conventional current flows from positive to negative, around that way, so electrons are actually going to be flowing this way around the circuit. Okay? Again, they're going to keep going in this path continuously. Okay? They're still transporting energy, but they're moving always in the same direction. So that's the difference between DC and AC. Some applications can use AC directly. A lot of light globes, incandescent light globes, can use AC directly. A heater might be able to use it, a kettle, but complicated electronics like computers, iPods, iPhones need direct current. Alternating current messes with their computing powers. So at the end of the first video, I recommend that you write down your own definition of alternating current and of direct current, and try and include a graph and a diagram of what's happening in each situation. You should also record what's happening to the electrons, the flow of electrons, what's happening to the conventional current, and what's happening to the voltage in alternating and DC situations. You should also have a look at the first link below, which links you to some applets, which will give you a bit more information about AC and DC and help you to visualise it. Then you can move on to the next video, which is about the objectives of rectification.